welcome to our Expo video. This year, Ethan Kelly, Ahmed Hamad, Marwan Ali, and me, Ethan Neighbors, were tasked with creating a lightweight lobster trap hauler. Abegweit Fisheries operates out of many wharves across eastern PEI. They came to the FSCE looking for a mobile and lightweight design capable of lifting and lowering lobster traps to and from a fishing wharf on landing and setting days during lobster fishing season. On landing and setting days, fishers need to transport 300 traps per boat, using upwards of 9 fishing vessels in total to transport all their traps out to sea or back to the wharf. The current loading process requires fishers to lift the traps between a wharf and a vessel, where the height difference can be upwards of 7 feet. This current process is physically intensive and time-consuming for the fishers. So, how are we going to solve this problem? Well, for the design to be effective, it had to be lightweight and modular, being assembled in 10 minutes or less by no more than 2 people. It had to be quick to prevent fishers from returning to their current loading process, and load traps at a rate of at least 60 per hour or 1 per minute. To be quick, it had to be strong and lift 2 traps at once. Each trap could weigh upwards of 100 pounds, and so the design needed to lift a maximum load of 200 pounds. The design also needed to transport traps regardless of the height difference between the wharf and the vessel. Therefore, the design needed to lift a load a distance of at least 7 feet. Finally, the design would need to operate in a marine environment, and its metal material added for strength would be at risk for corrosion due to plenty saltwater exposure. Therefore, the design needed to be corrosion resistant and comply with international standards. The team picked stainless steel as a material to comply with this standard. To verify these requirements, the team did a combination of analysis and prototype testing. The prototype was a scaled 1:4 model of the final design, and therefore during testing, the weight requirement and the height distance requirement had to be scaled by 4. Therefore, the design needed to lift a load of 62.5 pounds at 2 feet high to be successful and comply with Canadian standards for lifting devices. The design was successful, and further analysis determined the full scale would also be successful. The boom would only deform 0.67 or 2/3 of an inch with a factor of safety of 5 at a loading of 1,000 pounds, complying with the Canadian standards. To determine the trap loading rate, the team conducted a test with the prototype, timed the procedure, and interpolated the results by substituting prototype winch lifting and lowering times with times obtained from the full-scale design winch specifications. The average time was 1 minute and 52 seconds. The prototype could also be assembled on average in 5 minutes by 2 team members. From this result, the team believes that the crew members should have no difficulty assembling the full-scale design. We hope you enjoyed our little explanation about our design this year. Please feel free to come check it out at Expo on April 22nd. See you then.